All right, so this is the second video about inverse. The other video covered the definition and a few different examples, and now I'm going to get into some very specific algebraic examples. So the idea here is that when you have an inverse, you need to recognize that any letter that is given, F, G, in this case, N, they're actually just Y. Okay, and once you have that, to find the inverse, the definition of the inverse in algebra is to switch the domain and the range and vice versa, which are represented by these two letters. So once I do that and I have that switch, this will now be an X and this will now be a Y. And what I'm going to do is I'm going to then just drop everything else down that is above it. Now, please remember that what you're doing is you are inversing the order of operations from the bottom to the top. So I'm always just going to start at the bottom and ask myself, is there anything to inverse for addition or subtraction? Just like you always have been doing, we're just using the word inverse. So the first thing that I see is I see that I can inverse this 6. So we can either add it like this, right, which is a common thing, or to save space, we could add it over here. And again, you can do it however you want, but I'm showing you this as the last algebra thing you see in this class. I'm showing that to you as an alternative. So these will inverse out, bye-bye. And then what will happen here is I'll get x plus 6 is equal to 2y squared. So looking at this, we did this step. Now our next step is to worry about multiplication or division. There's a multiplication right there. So one way to do it is to divide by 2, right? The problem is students will do this, they'll forget to reduce it. The other way to do it is to multiply by a half, right? So if I multiply each of these by a half, again, I save a little step, and I'm also just showing a different version of how to solve than maybe you're used to before you move on. All right, and I reduce this. 1/2 of 6 is 3, and these will inverse and cancel, and then I have y squared. And my last step would be to square root the square, because those will inverse. Just make sure you square root this entire quantity. And oftentimes we include a parenthesis so people understand that. And so our final answer is the square root of 1/2 x plus 3 is equal to y. Now, to make sure we hit home this concept of inversing, this says n of x. So technically, I need to have right here that I have found the inverse. Otherwise, it's just a normal function. Why? What does that mean? Well, this is actually the inverse of n. So we want to say that as our final step in the process to denote that it's an inverse and not just some random function called y. All right, here's another graphing example. And remember, the idea here is that we are going to find a reflection of this over the line y equals x. And you know, one of the things we have to remember here is that when we do this and we find this line y equals x, it can be very confusing to do this by hand. Again, you're trying to find equal distances from this line. If you're great at geometry, it works. However, we want to inverse this function. So I mentioned earlier that you need to have at least 3 points. But if I look at this function and I look at these two vertices, I don't know that 3 points works. So I'm going to actually do 4 points to include these end values to make sure, you can see some of them might actually be on the same line, to make sure that this works out the way I hoped. So this point is -5, -2. Its inverse is -2, -5. This point is, oh, check this one out. This point is -2, -2, which means it is its own inverse, which means the dot will be in the same spot. This point is 0, 3. And this point is 3, 3. So it will also be its own inverse. So what an interesting example, because when I inverse this point and I get -2, -5, that point will be there. But when I inverse this point, if I reverse this value, it's the same value. It's going to be right there again. This point will inverse to 3, 0. And this point will be its own inverse as well. And so the zigzag that we have here is inversed to look almost the same over there. And you can see it, like if you, here, I'm going to highlight it so it stands out a little better. Looking at that value, right? Looking at that inverse there, it is the same shape and it is reflected over that line. And those are the two like litmus tests to make sure you got it correct. All right, our next example has a cube on it. So same process. Okay, I have an R, big deal. It really means Y. Okay. And then I'm going to switch X and Y. And then I'm going to drop everything else down that was there originally. And then I'm going to inverse each one of the values one by one. So again, I could subtract 16 down here. If that's what you want to do, that's fine. I am focusing on this idea just to make sure we're ready. Okay. So there we go. And then here we have X minus 16 is equal to 4y cubed. And again, you could divide by 4. Nothing wrong with that, except you might miss a simplification. So we're now going to focus on the idea that multiplying by 1/4 is a more traditional way to write the inverse of that. Okay, so that cancels out. And here we'd have 1/4 X. And then again, it's 1/4 of negative 16, which is negative 4. And then our last step is to take the cube root, not the square root. That would be wrong. I got to put a little 3 there. All right. Canceling these out. Now, that is my answer. However, rather than writing the answer just like this, okay, which, technically is the inverse, it's not denoted properly. So I want to make sure I come back and say, okay, this thing says R. So my answer, which I'll put over here because I don't have room, should say R inverse. So it would look like this, R inverse of X. Yes, it is a requirement that you rewrite that one more time. Okay. And so again, I mentioned earlier that sometimes we put a parentheses on that to denote quantity, which is fine. Don't forget to do that if you need to. Okay, so looking at the next thing, we have another graph here. And so looking at this graph, this is a parabola graph. So how would I look at the inverse of that? I am switching back and forth just to make sure we're doing all right with things. So this one would easily be denoted in that way. And so not a problem. And if I want to look at the inverse line again, which is y equals x, the inverse is going to reflect over this line. And you can immediately see if you have a point on that line, it's going to be in the inverse as well, because you can't inverse a point on the line without it being reflected to itself. So like looking at this point right here, this point is 0, 0. The inverse will also be there, right? Looking at this point here, this point is 0, 1. This one will now reflect or inverse. So this one inverses to itself. This one will inverse to 1, 0. Okay, you can see there's a little distance there that we can put in. Forgive me, my eyes were bad. It is 1, 1, so it will reflect to itself. My apologies. Anything on this line, anything on the line y equals x is going to reflect to itself. I guess my brain was kind of thinking about this one or something. So this one is not on the line. It is negative 1, 1. And when I reflect that one or inverse that one will be 1, negative 1. And so my inverse, as you can see, right, is going to be a parabola shape going this way. And just be cognizant of these arrows, right? If these arrows are going up, the inverse is not going to be going up. Just think of it like that. It's not necessarily going to be going down. That's not how it works. It needs to be reflected. So like if I reflect this arrow across that line, it makes sense that it's over there. If I reflect this arrow across the line, it makes sense it's going that direction. It's a reflection, not a flip over. Okay, so now we're moving into a more recent concept for us, which is inverses of exponentials and logarithms. And so remember, it's important to understand, looking at the order of operations, the order of operation tells you what you'll do here, which is super convenient and awesome. We're going to be looking the same thing, but when we get to this step, if I have an exponential, I'm going to use a logarithm. And if I have a logarithm, I'm going to use an exponential. All right, so let's take a look at what that looks like. So right here, what I'm going to do is, again, same thing. This is really y. It's an important first step. Once I do that, I switch x and y. So this will be x. My exponent will now be y. Everything else drops down. Please keep in mind, this is technically also a quantity, which can be important. Okay, and so I'm now going to inverse each operation from the bottom to the top. I have to add or subtract, which means I'm going to subtract on both sides. Okay, those cancel, they inverse each other. All right, and then next thing I'm going to do is look for multiplication. And this is where people often go wrong. And this is why using the fraction notation is so important. If I multiply this by a third, it will not actually do anything to the exponent. So I need to log base 3, right? If I log base 3, that will eliminate that or inverse it. Now over here, I'm going to log base 3, and this is when the quantity thing really becomes important. Log base 3 of all of that. You've seen me talk about it in the previous examples. All right, so once I log base 3 that, and cancel this out, this will drop down, giving me y minus 2. And my last step is to simply add 2. Now you may say, why are we going back to the bottom? Well, there wasn't a multiplication or division step. We did this, and now we're inside the grouping symbol, and that means go back to the bottom. Remember that grouping symbol that I had there? So now we're going to add 2 to both sides, and that will go outside of this quantity because it wasn't logged, remember? So it's really important to be paying attention to your quantity symbols. This was logged, the +2 was not. All right, and that gives us our final answer. But again, it needs to be written in inverse notation. So h inverse of x would equal log base 3 of x minus 4, and then +2. Now over here we have a graph. It's not necessarily the graph of this, it's just a graph of an exponential. And so one of the things we have to remember when we're looking at this line that it's going to be reflected over is that, and this is an important concept, is that when we do this, and we've already selected the 3 points for you, you want to pick points that are easy to recognize, like this point right here is 0, 1. Recognize that from your key points, right? So here we pick the point 1, 2. And here we pick the point 2, 4. And so try to pick points that are in those crosshairs. All right. And then one more thing that's important to understand is that this graph has an asymptote, and that asymptote is y equals 0. Well, that can also be inversed. To inverse this, we would now have x equals 0, right? So in addition to inversing these points, right, if I inverse this, I would get 1, 0. And if I inverse this, I would get 2, 1. Okay, and if I inverse this, I would get 4, 2. All right, we also inverse the asymptote, and it's kind of interesting. This gives us the graph of a logarithm, right? You could see a graph of a logarithm right below it. And it makes sense. Looking right here, the inverse of an exponential is a log. So that even happens in the graph. So it's important to also inverse not only the points, right? Inverse 1, 0 and 2, 1 and 4, 2. It's also important to inverse the asymptotes for this and the next one. All right, last one in the examples of algebraic problems. So again, make this a y. Now we have a log. Remember, this is log based. Remember, no log means the base is 10. Okay, oops, I was talking and didn't realize I forgot to make that an x. My apologies. Oh, no, I think I'm okay. So that's a y and that's x. Forgive me for talking and losing my train of thought. All right, the next step, there we go. So the first step is to just write the v as a y. And then the next step is to reverse your x and y. There we go. There we go. And then write everything down. And then after I do that, start inversing operations. Now this one's interesting because none of the addition or subtractions are outside of the quantity symbol. So I have to skip this step and come back to it when I get to the grouping symbol. I first need to get rid of multiplication, which I'm going to multiply by the inverse fraction. Again, I skipped addition and subtraction because it was in the grouping symbol. So that will inverse, giving me 1/2 x is equal to log base 10 of y plus 4. So we've done skipped this step, did this step, we're now at this step, and the inverse of a logarithm is an exponential. And so what you do is you base 10 that, canceling here, and then making this an exponent. That now becomes a little tiny exponent like this. All right, and then my last step, my quantity has now been released from the logarithm, so I now will subtract 4. And again, it's not in the exponent. It has to be down here. So if it helps you, you might want to put this in a parentheses to understand I'm 10 basing only that quantity and not the 4. So these would cancel out. And so my answer would be 10 to the 1/2 x minus 4 to help you. If you want to put a quantity, do that. And then equals y. And then the correct way to write that would be v inverse of x is equal to 10 to the 1/2 x minus 4. Looks like I wrote that a little sloppy, so I'm just going to fix that for you. 1/2 x. There we go. So when we do a logarithm, again, there's an asymptote. You can barely see the blue line right there. And so that asymptote, that one is x equals 0. So we're going to inverse that, and the inverse of that will be y equals 0. So keep in mind that now we have this asymptote here. That is the inverse of the original. And then the next thing we do is we find 3 points. So clearly I have a point right there at 1, 0. And then my next point is this point, which is 2, 1. And then I have another one at 4, 2. Again, this is not this one, because this would actually be a 10-based one, and it would be very far away. So keep in mind that sometimes this third point is like way off the graph. So sometimes you have to only use 2 depending on what you can actually find. All right, so I'm going to inverse this point, and so I will have 0, 1. I'm going to inverse this point, so I will have 1, 2. And I'm going to inverse this point, so I will have 2, 4. Okay, and you can see by doing this, I now have an exponential. And again, for those people who like to sort of understand the math and not just get it done, it's kind of cool how it's showing you right here that that's what you should get. And again, the line y equals x, which would be down the middle, that was kind of busy, so I'm going to do it at the highlighter. The line y equals x right here, you can see that beautiful symmetry along that line. All right, got one more video to talk about something called, it's actually a property. You can see it right here. So that'll be our last video on inverses.